Hello, my name is Ken Novak. I'm an engineer with the Bureau of Reclamation, and I'm here to talk to you today about our Colorado River Basin water supply and demand study. So really, we've been able to get through a number of droughts using our stored water very effectively. However, in recent times, we've seen drought, we've seen increasing demand, and really that's put a strain on our reservoirs, and that's really where we are today. We're able to meet our demands, we're able to meet the water use needs in a lot of the communities that rely on the Colorado, but in the future, it's more uncertain. And we really wanted to look at what do the demands look like in the future, what do the supplies look like in the future, and how do we make that a sustainable resource for future generations to come. So in 2010, Bureau of Reclamation and the 7 basin states that share this resource embarked on this Colorado River Basin study. And the objective was to look at water supply and demand over the next 50 years, and then look at opportunities and strategies that could potentially mitigate whatever vulnerabilities we're finding with those different scenarios going forward. As I mentioned, this was a collaborative effort, so it was Bureau of Reclamation, our 7 state partners working together, and then we had stakeholders throughout the basin representing a wide range of interests. So really, I think we had a complete picture of all the forces and interests on the Colorado. Ended up being a 3-year effort, so we started in 2010, we published in the end of 2012, and really that provided us a long time to work with these stakeholders, work with these states, and develop what I'll call momentum. We really came to a common understanding of a lot of things and understanding the challenges ahead, and that really resulted in no decisions, but what it provided was this common technical foundation for planning for the future, and that really provides us that momentum. We have a common technical foundation that really we can draw from as we have to try and make these difficult decisions and plan for the future. It's difficult to forecast the next year or 2 years of flow on the Colorado, never mind forecast out demands and supply over 50 years. And so very quickly we realized that if we're going to try and pick what's likely to happen on the Colorado over 50 years, we're only going to ensure that we're wrong. And so we use this scenario planning approach where we acknowledge that we know generally where we are today, but as we go forward into the future, that becomes less and less certain. And so it kind of creates a cone of uncertainty. And so by 2060, there's a lot of uncertainty. And we identified the major factors that contribute to that uncertainty. Supply, how much water is going to be available in the future? Demand, our communities and the economy is going to continue to grow in a way that continues to strain and demand more water from this already strained resource. And then how are our reservoirs going to operate? That's another uncertainty. And so really we tried to fill out that cone of uncertainty, the range of possible futures with different supply scenarios, different demand scenarios, and different operational scenarios, so that when we model the system using our planning tools, we can really see not just where the difficulties are, but where we can do okay. And that really can help guide robust planning and decision making. So when we marry those two together, supply and demand, we look at all of our scenarios, we end up with the figure you're seeing right now. What you're seeing right now is the fruit of that labor. And on the y-axis, you see volume in millions of acre feet. And on the x-axis, you see years. And you can see the running averages of those data we looked at earlier, supply and use. And you can see that they're converging at present time. And when we look at our scenarios going forward, demand being in red and water availability or supply being in blue, you can see that they're diverging more and more. And when we get out to 2060, sort of the median imbalance between demand exceeding supply is 3.2 million acre feet per year. But it's really important to emphasize that there's a huge range there. It can be as small as 0, or it can be as large as about 8 million acre feet. And so that's really the context that we embarked in our modeling and our evaluation of future opportunities, recognizing that we have an uncertain future. We want to understand what would it take to make an 8 million acre foot deficit viable or sustainable and meet demands versus what would be needed for a 3.2 or a 0. And we're really able to explore those different scenarios using our modeling tools, and again, contribute to a sound technical foundation that can provide all of our stakeholders and interest groups the information to understand what really needs to be done. Now, it doesn't say how it needs to be done, but what are the challenges? Just agreeing on those is really important, and having that general vernacular, the general understanding of the system and those challenges is a huge step forward. And I can't underscore that enough, because being on the same page with someone is the first step to moving towards a solution. And so that's the first half of our study, supply and demand, what are those scenarios? And now we move into what I'll call the second half of our study, evaluating the system, trying to see how reliable, how resilient it is under all those different scenarios. We looked at our system using metrics for 6 different resource categories. The Colorado obviously supplies water, so we had water deliveries, but we also have electric power resources. We have ecological resources, recreational resources, we have water quality issues, and then we also have our objective of providing flood control. Now obviously we're talking about a lot of scenarios where there's an imbalance between supply and demand, and perhaps flood control isn't something that would be a concern, but if we look at our climate change hydrology, we actually see that there's some likelihood of really high flows mixed in with a decreasing trend. And so making sure that our system can handle those flows and provide that flood control is really important as well. And so you'll see in the graphic shown on right that we've got all these colored dots, and each one corresponds with a location in the basin that we're monitoring for one of these resources, and you can see by the color which resource it is. And when we model the system, we can look at all of these 90 different points and really get a feel for how is it performing under a given scenario of supply, demand, and operation. And then that helps to identify a baseline of what are the vulnerabilities, what are our risks, and then that helps inform what might need to be done to mitigate those risks and vulnerabilities. So once identified, the risks and vulnerabilities under a baseline, say a do-nothing scenario, we went out and we said to the public, to anyone interested, give us your best ideas. Give us the options and strategies that you think are going to help to make this system more resilient and reliable going forward. And so over a 3-month period, we received over 150 submissions, and they were a range of ideas. Crazy stuff. I mean, really crazy stuff. Towing icebergs from the Arctic down to Southern California. This is real stuff that we got and we evaluated, but also really practical solutions like conservation and things that can be done pretty quickly. And so we grouped them into 4 major categories. We saw increased supply, we saw decreased demand, we saw modify operations, and then we saw things like community roundtables, and we called those governance and implementation types of options that maybe don't necessarily create water or reduce demand, but change the paradigm, and that obviously can be important as well. So one thing we recognized is that none of these are silver bullets, and we probably need more like silver buckshot. And the way we accomplish that is through a portfolio approach. And so we take various options that fit together based on what we're calling a strategy. So maybe you have a low energy approach. So what are the options that don't need a lot of power and are easier to implement from that regard? Or maybe you have a really high reliability strategy where I need the water every year, year in and year out, and I can't afford to not have it. So those are strategies, and then you group options together based on that strategy, based on how well something performs. And you can see that our graphic here shows that you have a pie now, and the pie fills the gap between supply and demand using those different options that fit with your strategy. And so for the purpose of our study, we looked at creating 4 portfolios. Now they're not solutions, but more examples of how you might come up with different strategies and then implement them and see where those trade-offs start to occur based on your approach to solving the challenges in the basin and really where your interest is, because that's going to affect your strategy, obviously. So we've now modeled a baseline scenario in the Colorado using our tools, our modeling tools, our metrics. We've seen what the system looks like in terms of the imbalances, the vulnerabilities to these various resources. And now we model it again under each of these 4 portfolios, resulting in a general 5 groupings of scenarios, if you will, based on what you're doing to address the vulnerabilities. And what I'd like to talk about a little bit now is some of the results that we got from that effort. And so, as I mentioned, we had a number of metrics across the basin, and so there's a variety of ways to look at it. But as one example here, I'm providing a water supply centric view of the upper basin in the Colorado and its ability to deliver its compact entitlement to the lower basin, and then a lower basin water supply view that looks at Lake Mead's pool elevation. Lake Mead is one of our two major reservoirs, and Las Vegas directly pulls water out of Lake Mead. And so the elevation of Lake Mead can be very important for their ability to extract water. And that's what we're looking at here, the ability of one basin to deliver its compact obligation to the other, and looking at that as a potential vulnerability if it can't. But then also the elevation of this key reservoir and seeing, is it dropping so low that there could be potentially challenges for Las Vegas getting its water directly out of the lake. And so this figure shows results broken down by the hydrology, the supply scenarios. And the first one, looking across the first row, is observed resampled. And so the paradigm here is simply that history repeats itself. And if history repeats itself, you see that the upper basin can deliver its compact entitlement to the lower basin with no problems whatsoever. The baseline has zero vulnerabilities, and as a result, all the portfolios have zero vulnerabilities. Now for Lake Mead, the lower basin sort of bellwether for water supply availability, we do see a few vulnerabilities cropping up. You can see 7% of the traces we were looking at, that's individual realizations of the next 50 years, had some problems where Lake Mead fell below that elevation. However, when we look at our 4 portfolios, we see that all of them were able to remedy that situation and bring it down to zero vulnerability. Now we've got a couple of other different hydrology scenarios that we looked at, but I'm going to cut to the bottom one because that's an interesting one. It says downscale GCM projected. This is really our climate change scenario. We take our climate models, we look at the hydrology output, and that drives the supply, the water availability. And so what we see now for the upper basin, its ability to deliver its compact entitlement to the lower basin, there's quite a few vulnerabilities. And when we start implementing our portfolios, we see that they're not able to mitigate all of those vulnerabilities entirely. Portfolio A was our broadest portfolio. It's sort of our kitchen sink, really throwing anything that's reasonable at the challenge and not really trying to limit things based on cost or based on other potential impacts. And then Portfolio D was really our smallest portfolio. It was kind of the common ground where everyone generally thought these were good things to do. And as a result, it has the fewest options to pull from. And so you can see that Portfolio A does the best, gets it down to 3% vulnerable from 18, but Portfolio D only brings it down to 11%. And so that speaks to your portfolio selection, how you craft your strategy, and ultimately what you can achieve. We see similar results when we look at the lower basin vulnerability, Lake Mead falling below elevation 1,000. What we see is actually that for the baseline, the do nothing, 44% of traces were showing some sort of a challenge where Lake Mead's falling below that 1,000 threshold. So that's a lot. When we look at our portfolios, however, we see that you can bring it down to about a quarter, 11%, using that Portfolio A, again the biggest portfolio, kitchen sink, but that Portfolio D, the smallest, only gets it to about 18. So again, once you start thinking about your strategy and what's included, you can then understand why you're getting the performance you are. The basin study completed in 2012, but in 2013 we launched what we're calling Moving Forward. And this is really building on that momentum. We identified a number of things in the study that were ripe for further investigation, maybe things that we couldn't get at for whatever reason during the basin study. And this effort aims to bring in the right stakeholders, technical experts to make that happen. There's a phase 1, and that's what's wrapping up right now. And the reports will be published in early 2015, documenting what these groups did and how it really shapes what we're calling phase 2. And so phase 2 is really looking across these work groups and the reports that they've generated and looking for common ground for things that we can do that will have multi-resource benefits and really starting to actually do things in a pilot project type of phase. And so that's where we're headed, and that's where we're directing and using this momentum to really start doing things that hopefully will help to sustain and ensure the viability of this important resource, the Colorado River Basin. So I'd like to thank you for this opportunity to share this study with you, and hopefully you found it interesting and informative, and would certainly welcome any questions or comments by contacting the email address shown on this slide here, and be happy to follow up with you. Thank you.